Hello everyone, Shashank this side. I hope you all are doing well today. So today we'll be looking at Transit Gateway as a solution for multiple VPNs. So basic idea is I'll show you instead of maintaining multiple virtual gateways at AWS we'll be using only one transit gateway and try to establish a connection from instances in one region having multiple VPCs communicate to the other region which is acting as an on-premise data center for us. So I don't have any on-premise environment. So what I have done, I have created a VPC in AWS Frankfurt region, which I'm treating as an on-premise data center. I'll be creating an instance and installing a software VPN, which is OpenSwan in this case, and we'll be treating that as an on-premise data center. So the basic idea is we'll have multiple VPCs in Northern Virginia that is communicable with each other with the help of Transit Gateway. So we are not using peering connection over here that we have learned with my previous video. And we'll try to check or we'll try to ping or do a telnet from instances in Northern Virginia, whether they are able to communicate instances in Frankfurt, which is like an on-premise data center for us. Again, if you're not aware of the site-to-site VPN, how it works, how the configuration works, please do watch my AWS site-to-site VPN video. That will give you a clearer picture before starting with this particular video. So let's start with that. Okay, so as you can see, we have multiple VPNs, 1, 2, 3, 4. All VPNs are communicable with each other with peering connection. This is the condition before our transit gateway. And we have multiple VPN connections going to our on-premise data center. So this is how it looked like when it comes to peering connection and multiple VPNs. What happens if we implement transit gateway? So we'll have one transit gateway that will communicate with each VPC and will help us to have a communication with our on-premise data center. How this will gonna happen? We're gonna take a look in a while. So again, if you're not aware of the transit gateway concept, please do watch my first video on transit gateway. That will give you an understanding of why transit gateway came into picture, what are the problems it's resolving for us. So again, a brief idea, removing and maintaining multiple peering connection and removing the concept of using multiple VPNs with multiple VPC, that is something getting vanished off with the help of one transit gateway. So we are only maintaining one transit gateway with all the routes that we have. So let's jump to our AWS management console. So this is my AWS management console. So I have created a scenario where we have three VPCs. You can see the CIDR block 1, 2, 3. These are communicable with each other. So instance in VPC 1 can talk to 2, can talk to 3 and vice versa. So this is the same thing that what we have done with the help of Transit Gateway with my previous video. I have created three VPCs. With help of Transit Gateway, the instances are communicable with each other. So if we go to the Transit Gateway, so I have created one Transit Gateway, and if we go to the route table, we have route for all these three CIDR blocks in association with all the three VPCs that we have. For the route back traffic, if we go to the VPC routes, each of the VPC route has been added with /8 and the same with VPC2. So basically we are trying to establish traffic from both sides, from transit gateway to VPC and VPC to transit gateway. Again, these all has been covered with the previous video of transit gateway. I'll share the link and you can go through that. Okay, so this is Northern Virginia, and if we go to our Frankfurt region, I have only one VPC over here with 10.20.0016 CIDR range. We have one subnet which is in public. We have one route table which is attached with the internet gateway. So first of all, what we're gonna do, we're gonna provision a machine, EC2 instance. So we are treating AWS Frankfurt as my on-premise data center because I don't have any on-premise environment. So we'll be installing a software VPN, which is OpenSwan, on one of our Linux instance. So let's spin up an instance, launch an instance, Amazon Linux. I'll go with T2 Micro. So let's select our custom VPC, enable our public IP. and you can see it's in central 1A. Add storage, 8 gigs would be fine. Name and open SWAN. Configure the security group. So let's say SSH. From public world, I'm gonna have ICMP from public world as well. So let's do that. Launch, select the key pair, launch an instance. Okay, SSH already exists. Okay, let's go back over here and rename it. Launch Linux 1, launch an instance. So this will gonna take a minute to spin up an instance. So for meantime, we'll go to our Northern Virginia region and we're gonna spin up a transit gateway attachment. So let's see. So you can see like VPN is already deleted, so you don't have to worry about this. So let's create a new attachment and we're gonna have the same transit gateway ID that we have used to communicate with each other of instance. And again, before doing that, I just wanted to show you the ping status for all the 3 instances. So that will give you an understanding that transit gateway is working. So I'm gonna log into my first instance. Let me maximize it. CD downloads ssh-i windows ec2-user at. So this is my first instance, which is in VPC1. So I'm gonna do ping and let's grab the IP of second instance, which is private IP 10.205. Paste it and we are able to see the ping response. Same way, I'm gonna have VPC3 instance private IP address ping, and we are able to ping from 1 to all the other 2. So let's log into VPC3 instance with another terminal window. Let me maximize this. CD downloads ssh-i windows, then we have ec2-user at. This is VPC3 instance. Now let's grab the private IP address of VPC2 instance and try to do a ping, and you can see we are able to ping from 3 to 2, and I'll do same for 1. Let's copy the private IP address and try to ping, and we are able to see the response. So we have one transit gateway which is allowing all the 3 VPC instances to communicate with each other. So let's go to our transit gateway attachment. We're gonna select the transit gateway that we have now. With the previous video, we selected VPC. With this video, we're gonna select VPN. And we'll be creating a new one because I don't have any customer gateway. So customer gateway is acting as a router, like an anchor at customer end, that on-premise end. And virtual private gateway acts as a anchor at AWS end. So we are not going to create virtual private gateway. So let's have the static route, and for that I'm gonna pick the OpenSWAN public IP, paste it, and let's keep everything as default. So our attachment is getting created. Close it. So this was the deleted one. Let's refresh this. This is the one which is in pending state. So let's give this name as VPN TGW. So if we go to site-to-site VPN, you can see that we have one is in the pending state, which is getting created with a customer gateway IP address this, and this is the customer gateway IP. This is the one. So again, if you remember, like with site-to-site VPN, we had to create virtual private gateways. So let's assume that we have multiple VPCs, and from each VPC, you have to create a site-to-site VPN to a customer end. So in that case, you have to create 4 different virtual private gateways. So instead of doing that, we are going to use a single transit gateway, and we just have to maintain that, as simple as that. Again, this will gonna take some time in, so we're gonna take some advantage. We're gonna go to our Frankfurt, grab the public IP of instance, and we'll install OpenSwan. Okay, maximize it, cd downloads, and ssh-i linux 1 ec2-user at this. Want to connect? Yes, I want to connect. So we are able to connect to our Frankfurt instance. So let's go to sudo su to the root user, and we're gonna install yum install -y OpenSwan, and here we go. So we are able to connect to our OpenSwan. So for that, I have few commands over here, which is this. We just have to check this particular path whether this is uncommented or not. If not, then we have to do that. So we'll use vim, and you can see this part is uncommented. It is best to add your IPsec connection in a separate file list, which is fine. So let's escape this, colon Q. So that point of view we are good, and we'll be creating this file, and we'll be adding few of the entries. So for that, again vim and syscontrol.conf. So let's do shift I for entry of the lines, and let's go to the end, enter, remove the hash, and we're gonna copy this particular network section area. Let's copy and paste it. We'll do the alignment, and I'm gonna show you the configuration over here while downloading the file, so that should be fine. So let's save this, escape, colon WQ exclamation, and we're gonna restart the service. Here we go. So as of now, the OpenVPN the OpenSwan VPN is installed on Frankfurt region. So just we have to wait for our VPN tunnels, the transit gateway is coming up or not. So it's still in the pending state, and if you go to a transit gateway attachment, which is this one, you can see it's still in the pending state. So this will gonna take some time, so I'm gonna have this video pause. Once this is in active state, we'll resume the video and show the next set of configuration. So our site-to-site VPN is available, you can see that, and tunnel details are here. So it's still in the down state because we haven't done any configuration on other side of the VPN tunnel. And if we go to our transit gateway attachments and check, this is also available. So the next thing that we have to do, we have to add a route. So for that, what I'm gonna do first, so I'll be in gateway route, transit gateway route, go to the route and create a route over here. We'll be adding the CIDR block of other region, which is Frankfurt over here, like your on-premise network, 1020.0.0.16, and the attachment would be our VPN, which is this one. Create a table, active, and you can see in seconds. Yeah, this is done. The same way, we have to add something on our route table for each of the VPCs for the communication. So go to edit route, add route, and we're gonna have other side of the routing gets added over here, which is this one, and the traffic routing will go via transit gateway. save the route. Do the same for other VPCs, I mean the route tables, which is 10, 20, 16, transit gateway. And you can see like we are using a single transit gateway. We haven't created any other transit gateway. So it's all as simple as that in terms of the configuration. Go to transit gateway, save the route. So from routing point of view, everything is done. The next part, what we have to do, configure our open SWAN. So for that, we'll go to site-to-site VPN, we'll download the configuration file. So click on this and click on download. So we just have to wait for this to come up. So today somehow I'm facing this issue while downloading. It takes a lot of time. So in that case, what I'm gonna do, I'll log out to my account and log in again, because that is something a quicker way to download the file. So instead of waiting, we can do it very quick. We just have to sign in. I haven't faced this issue earlier, but today somehow the network issue is there. So okay, so let's go to VPC. I'm in Northern Virginia. Let's go to our site-to-site VPN and click the available one, download the configuration. You can see this, and we'll go for generic, download the file. Okay, so let's close this one. So this is the file that we have, where you're gonna see we have what VPN, we have customer gateway. This is the pre-shared key that we need to have. So let's copy this, and so this is something we have to create. So I'm just noting it down. So we have IPsec configuration, we have tunnel 1 configuration over here. You can see tunnel interface configuration. So this is the public IP, the customer gateway IP. So you can just copy and paste it over here. I'm gonna walk you through the configuration in a while. Just give me a second. This is the other side of the subnet, and this is the routing that we have. Something going from, since we have multiple VPCs, that's why I've taken a common route /8 from Northern Virginia to all. In same way, you have to edit for this pre-shared key. So pre-shared key is something required for the authentication. Okay, so let's close all these things, and I'm gonna go to my AWS management console. Also, I guess they have an option of open SWAN, which I forgot. So if I download this, and here you can see like for IP1, so whatever the things I am editing over here is this one only. So this is the configuration that we have to do in AWS conf file on VPN server. So that's why I have already jotted down. I have edited this IP, and this is the one with pre-shared key. So we should be good over here. And you can see the lines for the networking that I have added that was required to the syscontrol config file for configuration of the OpenSWAN. Okay, so cancel this, and we'll log into our Frankfurt. So I need to check what was the IP address of that, which is 1020.013. 1020.013. This is the one. Okay, so let's create a file which is vim shift I, and we're gonna copy the content, paste it, escape, :wq, done. The next one, for the pre-shared secret file which is required for the authentication, I'm gonna have that created as well, and shift I, we're gonna save this information over there. I'll just gonna cross check the values. Okay, so 52, 59, 248, 20. 52, 59 to 48, 20, and 52, 70, 190 to 119. 52, 70, 190 to 119. Got it. So this is the first IP is the public IP of the tunnel side, which is the VPN side, and the second one is something on our AWS side. Yep. Okay, so we have done with that configuration. Yep. Escape, save this file, done. And at last we just have to check the services. We have to enable services. Okay, just start the IPsec. So I guess we don't have any issue over here, and we'll check the service whether it's active or not. Here we go. It's showing active and running since 6 seconds ago. So our VPN tunnel configuration has been done. So we just have to wait for a few seconds. Not here. So if we go to where exactly on the site-to-site VPN on the tunnel details, so this will gonna take as per my previous experience, this takes around 1 to 2 minutes to come up. So since we have done only one tunnel configuration, we can do the other tunnel configuration in the same way. So as of now, you are gonna see this up and this is down. So we'll wait for it, and again I'm gonna have this video paused. Once this is up, I'm gonna show you the ping status. So our tunnel is up, tunnel 1, the configuration that we have done. So it's up and running now. So how can you test this is up and running? The best test is the ping test. So let's go to so I'm in Frankfurt, 1020.013. You can see or cross verify the IP address. Where is that? This is the one. 1020.013, and we'll take one of the IP address. Let's say instance 1 in VPC1. Let's try to ping. Here we go. We are getting a response. Same way, let's try to ping instance 3. Ping. We are getting a response, and the last one is second instance. Here we go. We are getting a response. In same way, I'm gonna show you. This is from Northern Virginia to Frankfurt. Are we able to ping it or not? So let's grab the private IP address of Frankfurt. So this is what, 10.309. 10.309 is my third instance. So let's try to ping. Awesome. We are able to ping from instance 3 in VPC3, instance in VPC3 to Frankfurt. 10.1 is VPC1. So let's try to ping from here. Here we go. We are getting a response. So you see, like, we have 3 VPN connection. We have 3 VPCs. All 3 VPCs are communicable to each other. And instead of creating 3 virtual private gateway for the VPNs at AWS side, we have created only one transit gateway. And with one transit gateway, we were able to we were able to make a connection to our on-premise data center, which is AWS Frankfurt. The same way you have to do configuration for your on-premise data center, or whether you're opening a connection to Google Cloud or Azure Cloud. Is just the level of understanding that in terms of configuration we have to check around. So that's how ease of communication happens with AWS Transit Gateway, regardless of your peering connection, regardless of your VPN tunnels. So just try it out on your account. Try to create multiple VPCs. Have your on-premise data center network CIDR block updated in your route table of your AWS cloud, and with the help of Transit Gateway, try to check whether you are able to make a connection or not. If you are facing any issue, just place out a comment in comment section and I'll be there to help you. Have a nice day. Bye-bye.